Hi there, this is Mr. Alexander, and today I want to talk to you about solving systems of equations using technology, namely the calculator. And I want to do that today by walking through some examples. So here we've got a system of equations, which is three different linear equations, and I want to know what the x, the y, and the z variables are. In other words, I want to know what where these lines cross. What's the coordinate point? Now, last class what we did is we used Gaussian elimination to figure out where they cross. Today I'm going to show you how to do this on the calculator. The first thing you want to do is write the augmented matrix. And a matrix is simply a place where we write the coefficients in front of the variables and the constants on the other side of the equal sign, and we stick them all together and make it into one box-looking thing. It's called a matrix. So the coefficient in front of that x is a 2, in front of the y is a -1, in front of the z is a -1, and then after the equal sign, that constant there, that's a 4. And in front of the x, the coefficient's a -1, a 2 in front of the y, a 1 in front of the z, and a 1 in front, or a 1 is the constant after the equal sign. Here, in front of the x is a 3, in front of the y is a 1, in front of the z is a 1, and then after the equal sign, that's a 16. So, we've got an augmented matrix here, and with this information, the calculator, which I've got right here, can tell us the solution, what the x and the y are, the x, the y, and the z. And what I'm going to do is I'm going to clear my calculator. That's second plus 712. You should always clear out the calculator before you use it. And we'll write down these steps in a moment, but I just want you to watch me do it the first time. If we go second matrix, it pulls up this screen. We want to go over to edit. Now, it's asking me the dimensions of the matrix. Well, this matrix is row by column. So there are 3 rows for 3 equations, and there are 4 columns. So in the calculator here, I'm just going to type in 3 by 4. And I'm going to type in this augmented matrix just like I wrote it. So 2, enter, -1, enter, -1, enter, 4, enter, -1, enter, 2, enter, 1, enter, 1, enter, 3, enter, 1, enter, 1, enter, 16. And from here we go second quit. And we're going to go back to second matrix, over to math, up to B, RREF stands for row echelon. Hit enter. But before you hit enter again, go back to the matrix screen and hit enter on matrix A twice. Now, as long as you see this nice, pretty identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1, what this is the calculator saying, oh, I solved your system of equations. Z equals 3, Y equals 1, and X equals 4. So from here, I can come back out here and I can say, oh, I know where these lines crossed. They crossed at 4, 1, 3. And that's the solution to the system of equations. That's where they cross. Just another quick note, make sure that you see 1, 0, 0, 0, 1, 0, 0, 0, 1. Make sure you have that identity matrix. If you don't have that, then you don't have a solution. You either have no solutions or infinite solutions. Now, I think that's important, those steps, so I want you to write them down. I'm going to show you here what they are real quick. The first step was we wrote the augmented matrix. The second step was second matrix, over, edit, enter. We set the size of the matrix and the type of the augmented matrix. Second quit, second matrix math, B, second matrix, enter. And that'll get you the solution every time. So I want to show you one more that looks like this. So the first step is to write the augmented matrix. So the number in front of the x is a 2. The number in front of the y is a 1. And then look, there is no z. Well, that z variable still has a coefficient. It just happens to be a 0. The constant is a 9. In front of the x is a 1. In front of the y is a 0, which is why we don't see it. In front of the z is a -2. After the equal sign is a -13. 0 in front of the x, 2 in front of the y, 3 in front of the z, 15 after the equal sign. So let's walk through those steps one more time. And we're going to get, let's see, so I'm going to clear out my calculator again. Second plus 712. And let's go matrix edit to 3 enter by 4 enter to 2 1 0 9 1 0 -2 -13 0 2 3 15. Second quit, second matrix over to math up to B, second matrix, enter on A, enter again. You've got this nice identity matrix, Z equals 11, Y equals -9, 1 equals +9. So the solution, 9, -9, 11. That's what the calculators told me here. And that's how you solve a system of linear equations. And you could do that with 2 equations, with 4 equations, with 5 equations. That works. So just because we've only done 3 equations here doesn't mean you can't use more or less. Something else I want to show you. Stuff like this. This is just 2 equations. Y equals x plus 2 and y equals x squared plus 4x minus 2. Now we can't use matrices here because those matrices only work with linear equations. This first one's a linear, but the second one's a quadratic. When we have the squared term, we're going to have to do something else. We're going to have to solve it graphically because remember, the solution is simply an xy coordinate where these 2 lines cross. So again, it's in the calculator. But this time, we're going to go to this y equals button right here, and we're going to type in the 2 equations, x plus 2 and x squared plus 4x minus 2. Now I'm going to hit that graph button. And I simply want to know where these 2 lines cross, and I can see that they cross twice. So this thing's going to have 2 solutions that are coordinate points x, y. The way you get them is you go second trace, and we're going to see where they cross. So we want to hit enter on intersect. Now I'm going to move my spider pretty close to the intersection point before I hit enter 3 times. Enter, enter, enter. One of the 2 solutions is 1, 3. So I'm going to write that one down. 1, 3. That's one of the times this thing's cross. And the other time, second trace 5. I'm going to move my spider pretty close to the second intersection point. I'm going to hit enter 3 times. The other coordinate is -4, -2. So all you really need to remember here is second trace 5 and then enter 3 times. That's all you really need to know. Let me show you another one like that. Right here. This time, we've got an equation which is linear and an equation which is quadratic. So I'm not going to use the matrices this time. I'm going to use y equals. I'm going to type in x plus 7 and -0.5x squared. If you're wondering where that x squared button is, it's right here, x squared. And plus 6.5x minus 5. And I'm going to graph it. And let's see. Ooh, looks like it crosses, but I can't quite see where it's at. This will happen on occasion. When that happens, go ahead and hit the zoom button or the window button. Either one's fine. For simplicity, I'm going to hit zoom today. And I'm going to hit zoom out. After you hit zoom out, you got to hit enter once. And hopefully you can see that this thing actually does cross twice. So it's the exact same process now. Second trace 5. Move the spider pretty close to the first intersection point. Hit enter 3 times. Looks like one of those is 3, 10. And the other one, second trace 5. Move on over. Enter, enter, enter. The other one is 8, 15. But what if you forgot about that zooming thing? What if you were staring at it like we originally did, and you're just like, uh-oh, I don't know. I broke my calculator. Let's try that again. Graph. I'm looking at it, and I don't know what's going on here. I can't see where it crossed, so I'm going to go to the table instead. If you do second graph, you're simply looking for where the y's repeat. So see that? 8, 15, 15? That means one of the solutions is 8, 15. And 3, 10, 10? Wherever the y's repeat, that's where the solutions are. Okay? So you got 2 ways to figure that out. Let's do one more right here with inequalities. Y is greater than or equal to 2x squared minus 22x plus 39, and y is less than or equal to 2x plus 7. We're going to type those in the calculator. So let me clear these out. 2x squared minus 22x plus 39 and 2x plus 7. Now if we go over here to where right next to the y1, notice that this says y is greater than, which means shade above. So if you hit enter a couple times, you're going to be able to shade that thing above. And y2 is less than or equal to, so I'm going to shade below, which is this guy. When I graph it, this calculator is going to do some shading for me. Now, I can see that's a parabola, I can see the quadratic, but I can't really see where it breaks up very well. So if I do zoom out, enter, I can see this thing a little bit better. There's my parabola, there's my linear, and so that's what it looks like. And you would just want to copy down that graph on the graph provided. And that's it. That's really the whole thing. There's one little caveat that you might need help on, and it's if you see something like this, we still want to graph it, but we want to solve it for y first. So this one's solved for y, the y is isolated, but on this guy, the 2y plus x equals 4, we want to get the y by itself. So you would want to subtract x, 2y equals negative x plus 4, and divide by 2, divide by 2, divide by 2. You get y equals negative 1 over 2x plus 2. So you want to graph this equation and this equation, and then do second trace 5. So that's it. That's how you solve systems of equations using technology. If you're worried because you don't have a calculator at home, I'm going to post another video on how to download one to your computer. So presumably if you're watching this, you have a computer. I'll get you a TI-84 Silver Edition for free. You just watch that video on how to download it. Okay? Bye.